Today we will discuss Chapter 5, which is entitled Boolean Logic in Programming. Boolean logic is algebra that operates on truth values. So you know algebra of real numbers, y equals 3x plus 5, things like that. Boolean logic is a different type of algebra. Instead of operating on numbers, it operates on truth values. Every truth value, if you recall from Chapter 4, is either true or false. It's one of two things. The operations that Boolean algebra performs on truth values are things like and, or, and not. And will take two truth values as inputs. So you can think of it like a multiplication sign, say. It's usually represented as a hat, if you recall from like an upside down V. And the truth value of x and y is true if both x is true and y is true, and false otherwise. The truth value of x or y is true if either x or y is true or both, and false if both x and y are false. Not is very easy to understand. Not is true. Not is kind of like a unary negation sign. So it's like negative x basically, and that just flips the truth value. So not x is true if x is false, and false if x is true. It just flips it. Other part of the chapter discusses ASCII and Unicode. These represent letters as numbers in a computer. So it's kind of a weird addition to this chapter, it's kind of thrown in. So for example, a number like 63 will represent a letter in ASCII or Unicode. Another point in this chapter is strings of characters, or strings for short. If you recall, that's a type that you can have in Alice. String is a type of variable in Alice. Strings of characters can be compared using dictionary order. So remember, dictionary will have words in alphabetical order. You can say that one string is less than another string if it appears before it in the dictionary. So that's a way to compare strings. And the rest of this chapter of Chapter 5 is basically devoted to algorithms. So let's talk about algorithms. Let's do a test program to learn about algorithms. In this program, we'll have the program randomly choose a name, one of two names to make it easier, and then the character repeatedly asks the user to input the character's name until the user guesses correctly. And then the character says, "That's right," when the guess is correct, and the game ends. So this is an algorithm, because every computer program is an algorithm. So let's think about how we might be able to do that. And I'm going to start Alice. And we'll take a look at this program. Once we get it running, here it is. We'll add an object. So grass is fine, and let's use the bunny again. Make the bunny face the camera. And okay, we're done. So now we're ready to start coding. So that was just set up so that we can start coding. So now we're ready to start writing our algorithm. And we'll just put our algorithm in world.myFirstMethod. We don't need any new events or anything. This is just thinking about the program. So let's look at this. The program randomly chooses a name, then repeatedly asks the user to input the character's name until the user guesses correctly, then says that's right when the guess is correct, and the game ends. So let's think about how we can do that. Well, one way to break up algorithms to make them easier to understand is to write them out in English beforehand. So this is just a text editor that I'll write some stuff in. And we'll use that to develop this program before we code it. So it randomly chooses a name, one of two names we said. Okay. So remember our tools for designing algorithms. We have commands, which can change the value of variables. We have if statements, which can let us do one of two things. And we have loops, which can do things over and over again. So first, the program randomly chooses a name. Well, in order to randomly choose a name, we need something that can choose a random value. And we can store the random value in a variable. And then we can do an if statement and select one of two names and put that in a variable. So I'll show you this function here called random number. So this function will randomly choose a number. So let's look at this. Okay, so the first thing we need to do is we need to randomly choose a name. So once we've randomly chosen the name, we need a way to save that name that we chose, such as by putting it in a variable. Sorry, I'm trying to... Alice tends to take a lot of CPU on my computer, so I'm worried about it overheating, but just leave it. So once we choose a name, we want to put it in a variable. So we're going to need a variable. So let's say, okay, let's say we have a variable x, string x, because it's a name, equals, and then nothing right now. And so now we need to choose one of two names. We need to, we can say, okay, number r for random equals this random number function, and we're going to choose between 1 and 2, and it has to be an integer. Alright, actually, ignore this, I'm just trying to make my computer not overheat. But it's actually, I don't think there's a way around it. Alright. Sorry about that. Back to this. So we've got our string, which is blank, and now we have a random number. We're going to choose 1 or 2. We're going to choose a random number between 1 and 2. and we're going to make it an integer, so it can't be something like 1.34827 or something like that. And now we want to choose one of two names. Well, what construct do we use to choose one of two names? To do one of two things. X is going to be one of two names, and we want to set a different name depending on what R is. So think about how we might be able to do that. It's the if statement. If statement lets us do one of two things. So if R is 1, then what do we do? All right, let's set X to Eric. And then otherwise, because remember, an if statement lets us do one of two things. So if this is not true, then we're going to set X to Sam. Alright, so now we've chosen one of two names for the bunny. So that part of our program is done. So now what do we have to do? Okay, after we've chosen the name, the bunny is going to repeatedly ask the user to put the character's name in until the user guesses right. So how can we do that? Well, if we want to repeat something, we want a loop. So can we just do a loop right now? Okay, while guess isn't X. Bunny say, what is my name? Alright, can we do that? What's wrong with that? Well, first of all, we don't have guess anywhere. Okay, so let's say, okay, create string guess equals Eric. Or no, equals nothing. Alright, and now while guess isn't X, say what is my name? Is this right? Well, no, it's not. And the reason it's not is because guess is never going to be set to anything. So guess is never going to equal X. And this loop will continue on forever. This is a very common problem with making loops. Is that things tend to, is that if you're not very careful, the loop can continue looping forever. Alright, so now we're going to set guess to ask user for a string. Ask user for a string is this Alice function over here. We can ask the user for a string. So now what? Is this okay now? Alright, well what's going to happen? Remember, the way to analyze a program is to go through it step by step, line by line. Alright. X is either Eric or Sam, and then we say, okay, guess is now the empty string. So no characters, so it's a string of 0 characters. A string is a sequence of 0 or more characters, so the empty string is 0. While guess isn't equal to X, alright, well X is either Eric or Sam, so it's not going to be equal to guess. Bunny say, what is my name? The bunny asks the user for a name. And now we set guess to the result of asking the user for a string. So we ask the user for a string and then store the result in guess. Alright, then what's going to happen? Well, this is the end of the loop. So we go back up to the beginning of the loop. And alright, is guess equal to X? Well, it is if the user typed Eric or Sam. One of those. We don't know which one, because we don't know if X is Eric or Sam, but we know it's one of them. So it might be. So the loop will end if the user guesses right. So therefore, this is right. This loop is correct. So now let's look at the program again. Alright, once the user guesses right, the character says, that's right, and the game ends. Alright, so our character is a bunny. So we're going to say, bunny say, that's right. And then the program ends. So that's the last thing we have to type because the program will end there. Now if you notice, I did all of this outside of Alice. And that's because these concepts are really universal to imperative programming. They're not limited to Alice. And sometimes it's easier to, just kind of scribble stuff out and think about it when you don't have to think about, okay, exactly how do I do this in Alice? And now that we have the general algorithm out, now that we know basically what we're going to be doing, it's going to be a lot easier to code this in Alice. So let's say, okay, what variables do we have? We have string x, number r, and string guess. So those are our three variables. So let's create some new variables. R is the only number that we need. Create new variable. X is a string. And guess is a string. So we've got our variables now. So now let's look at this. Okay. So now we need to set R to the value of that random number. So first we have to make a set thing here. So let's say, okay, set R to 1, and then we drag in the tile to replace 1, which has to be the random number creation thing. So set this to random number, and we need to choose minimum of 1, maximum of 2, and we need it to be integer only. So it's going to choose 1 or it's going to choose 2. So we've done that now. Now what? Okay, now we need this if-else right here to set the name. So if, and then we need an equality test. This is a function. If r is equal to 1, then we're going to set, I misspelled guess here. Then we're going to set x to Eric. So we say, okay, x set value to Eric. Now if it's not equal to 1, in which case it must be 2, we're going to set it to Sam. Alright, so now that part of the algorithm is written. We have chosen a random number and used it to determine what the bunny's name is. So now all that's left is our loop. And our loop is going to be a while loop. So while, we need another equality thing here. While x is not equal to guess. So it turns out that equality is only for numbers, so I needed to drag it from down here. While x not equal guess, what do I do? The bunny asks what his name is, and then we get the guess from there. So we need to make the bunny say something now. So bunny say, what's my name? And now we're going to set guess to ask user for a string. And guess set value to let's say enter a guess. And now this is going to loop until x is equal to guess, until the user guesses right. And so now we have the bunny say that's right after the loop. So now our program is written. So let's run it, see if it works right. Gonna restart it here. So the bunny does ask, what's my name? Alright, I'm gonna guess Sam. What's my name? Eric. That's right, alright, because it's got to be Sam or Eric. So now I'm going to add a little flourish to this. And if you guess wrong, I'm going to say, let's make the bunny say, no, that's wrong if you got it wrong. So that's going to actually complicate this a little bit, because we're going to have to add something above the loop. So I'm going to copy this statement, make the bunny say, what's my name, and then while x is not equal to guess, well, and then I'm going to have guess set value to whatever the person guessed. So guess set value to ask user for a string. Enter a guess. I'm going to undo that because guess set value to ask user for a string here. I just and now I'm going to make the bunny say right here, wrong guess again. Doing this quickly, but I'll explain it after I'm done. Alright, so now let's see what we did here. What I did was I copied the stuff in the loop and put it out of the loop. I put it before the loop. So we still go ahead and generate our random name. Then remember, the way to analyze this is to step through it line by line. The bunny says, what's my name? And the user gets to guess. And this is all before the loop. So now the loop will run as long as x is not equal to guess, so as long as the name is not equal to guess. Well, we've already taken a guess, so the user might have gotten the right guess, and if the user did get the right guess, then this whole loop is not run. And so then the bunny says, that's right, and the program ends. If the user guessed wrong up here, the bunny says, wrong, guess again. What's my name? And then the guess is set to the value of this function which asks the user for a guess. So that's what this is going to do. So what I did was I added the bunny wrong guess again when the user got the when the user guessed wrong. However, to do this, I had to make a few structural changes to the algorithm. Specifically, I had to put the body of the loop above the loop in slightly modified form. I don't have the wrong guess again above the loop, but I have the rest of it above the loop. So how did I know to do this? Well, you just... That's a tough question. Because the way I know to do this is I thought about the algorithm and what would be needed to add this, and then I did what was necessary. So this is kind of a thing that you just have to practice to really be able to do this quickly. But the way to do this is to think about the tools you have. You have commands, loops, and if statements. So you can have the bunny say things, so you have things that you can make happen in the world. You can set the value of variables, and you can perform tests that determine whether a loop is executed or which branch of an if-else statement is executed. And there are patterns, so this is a pretty common pattern. Putting the body of a loop before the loop in order to make the loop work right is a pretty common thing to do. In fact, it's so common that some languages have something called a do-while loop, which if you look in chapter 4, they call that a post-condition loop, embedded in the language. Alice doesn't. Alice only has this type of loop, so we have to go ahead and repeat the body of the loop above the loop in modified form. So it's easy to check whether it's right. Alright, we're setting the value of the name. Bunny asks the name. User guesses wrong. Bunny says that's right. Program ends. Guesses right. Bunny says that's right. Program ends. Guesses wrong. Then this is true. Then the name is not equal to the guess. Bunny says you're wrong. Bunny asks what your name is again. User inputs a name. Loop checks whether the guess was right. If it's wrong, loop continues. Bunny says it's wrong. What's my name? User guesses again. If the guess is right, loop exits. Bunny says that's right, and it's over. So think about this. Think about why this works. Be able to analyze this. Analyze it line by line, step through it, see what's happening, and then that will tell you why this works. And that's the first step toward being able to write these things yourself. When you need to do something, just think about the tools you have. Think about loops, if statements, and commands, linear sequences, what the textbook calls them. And think about how you can combine those elements to form a program like this that works correctly. And you don't have to do it in Alice. You can do it by hand. And if you write something by hand like here, and you're having trouble converting it into Alice, I will be very willing to help you out. If you know what you want to do in Alice and you're just having trouble with knowing what to drag in order to make that happen, just ask me on IRC or over email and I'll tell you what you need to do. Because the whole point of this is algorithms, not specifically how to program stuff in Alice. Alright, so this program is done. So let's look at our next program. How tall am I? Alright, so what this program is going to do, randomly choose a number between 1 and 5 and use that as the character's height. Then the character asks, how tall am I? That's right, character says, that's right, I'm not that tall, or I'm taller than that, depending on what the user guesses, and then the game ends. Oh, and let's just run this, just to show you that it's right. Wrong, guess again. What's my name? Okay, it must be Eric then. That's right. Alright, so this code works. And it's important to test it. So once you've written something out in Alice, obviously run the world, make sure it works. So back to problem 2. Randomly choose a number, ask how tall am I, and then say that's right, or I'm not that tall, or I'm taller than that. And then the game ends. No second chances. So nothing has to repeat in this game because you only get one chance. So we're probably not going to need a loop. So let's write this out and see what we need to do. Alright, so what's the first thing we need to do? Well, first we have to determine how tall the character is. So we have number x equals random number minimum equals 1, maximum equals 5, integer only equals true. So we want a random number between 1 and 5. Alright, now that's the height of the user. So instead of x, let's call this height. It's good practice to name variables things more descriptive than x, y, and z. Alright, so now character. So I'm going to make it an astronaut instead of a bunny this time. Alright, astronaut, say, how tall am I? Number, guess. So now after the astronaut asks how tall am I, the user should take a guess. So the number, we have another variable called guess. Set that to ask user for a number. Alright, so now we've got the height. The astronaut said, how tall am I? The user has guessed. Now we need to say one of 3 things. That's right, I'm not that tall, or I'm taller than that. So we need to do one of 3 things. How do we do that? Well, we know how to do one of 2 things, which is an if statement, but we can't do one of 3 things with just the if statement. So we're going to need more than one if statement, but that's okay. So if height is equal to guess, let's use that as the first comparison. Check if they're equal. If height is equal to guess, then the astronaut should say, that's right. Otherwise, what do we need to do? Well, we don't know, because we don't know if the guess was too high or too low. But, so we need another if statement. You can put if statements inside one another. It's called nesting them. So that's okay. That's a tool that we can use. Put an if statement inside of an if statement. You can put an if statement inside of a loop. You can put a loop inside of an if statement. You can combine these elements any way you want. So what we want to do is we want to have another if statement. We want to check if the guess is less than the height, let's say. So if the guess is less than the height, what do we want to do? Look at the specification. If the user guessed too low, we want the character to say, I'm taller than that. So let's make that happen. Astronaut, say, I'm taller than that. Alright, now otherwise, what do we want to happen? Well, otherwise, we know that they're not equal, and we know that the guess is not too low. So logically, if we know they're not equal, because if they were equal, we would have gone here, and then we wouldn't have executed any of this stuff, because we would have taken this branch of the if statement and ignored all of this code. So if they were equal, this would have happened and we wouldn't be here. If the guess was too low, the astronaut would have said, I'm taller than that, and we wouldn't be here inside of this nested else here. So logically, if they're not equal and the guess isn't too low, the guess must be too high. So therefore, if the guess is too high, we want the astronaut to say, I'm not that tall. And there's only one guess, so that's the end. This is the end of the program. Astronaut said either that's right, I'm taller than that, or I'm not that tall, and the program ends. So we're going to create a new world now in space, and we need an astronaut. It's fine. Go to space. Here's an astronaut. Make him face the camera. Alright, done with that. So now, let's go ahead and take this and translate it into Alice. Alright, so we need two variables. We need two number variables, height and guess. So two variables. One variable should be height. It's a number. One variable should be guess. It's another number. First thing we do, randomly generate the height. Okay. Drag height down here. Height set value to height. And then we go and get the random number function. Height set value to random number. Minimum should be 1. Maximum should be 5. Integer only should be true. So the astronaut has a height from 1 to 5. So now what do we need to do? Have the astronaut ask the user how tall he is. So that's going to be astronaut say. How tall am I? Alright, now we need to ask the user how tall the astronaut is and save the result. So the guess is going to be set to something here. Guess is going to be set to the result of a function asking the user for a number. I'll say enter a guess for the prompt. So now astronaut said how tall am I? Dialog box comes up and asks the user to enter a guess. Now notice what I did here. I couldn't just drag ask a user for a number in here because this is a function. And you can't just call functions in Alice. They have to be standing in for the parameter to a method. And the method is guess set value to. So users asked for a number, and the result of asking the user for the number is stored in guess. Alright, so now we've got the height and the guess. So we've got all of the data we need for the final bit of this program, which is this nested if-else sequence. So we need two if statements. One if statement is the outer one, and the other if statement is embedded in the else part of the first if statement. So let's go ahead and do that. If, and we need equality here, if height is equal to guess, then astronaut needs to say, that's right. Otherwise, have another if-else and put it in here. and we check if height is less than guess. So we have a less than here. Height less than guess. Oh, I'm sorry. Guess less than height, not height less than guess. Guess less than height. So if the guess is less than height, then the guess is too low. So we want the astronaut to say, I'm taller than that. Otherwise, we want the astronaut to say, I'm not that tall. Now, how do we know that this is true? How do we know that when we get here, the guess was too high? Well, again, trace the execution of the program. If the height is equal to guess, astronaut says that's right, none of this gets executed. We skip all the way down here, because this branch of the if statement is executed. Height is equal to guess, this happens, none of this happens. If height's not equal to guess, then this happens. If height is not equal to guess, but the guess is too low, this happens, and this does not happen. If the guess is not too low, then this happens. So if the guess is not equal and it's not too low, we know it's too high. And so we can safely have the astronaut say, I'm not that tall at this point in the program. So let's run this, see if it works. 3. I'm not that tall. Okay. How tall am I? I'll guess 2. I'm taller than that. Okay, so you can see, you just have to randomly guess. So, importantly here, we don't really know if it's working right. Because how do we know what the astronaut's height is? Well, that's what debugging printfs are for. So we can print out the height here. So print height, and then that prints to the bottom of the window. So we set the height, print the height, and then have the astronaut guess. Alright, how tall am I? Okay, it was 1. So if I say 3, I'm not that tall. Okay, restart. How tall am I? 1 again. Enter a guess. 1. That's right. Good. Okay, restart. How tall am I? 4. Alright, let's say 3. I'm taller than that. Alright, so it looks like it's working. So we can now take this and put it in the trash, because that was just to debug the program, to test and make sure the program's working right. So this is our complete astronaut guess program. Back here. Alright, these were the two test programs that I was going to show you to help you with the homework. Now this homework, if you're new to programming, it's hard. And the reason it's hard is because it requires a different way of thinking than you're probably used to. You've just never used these tools in this way to put stuff together. But it's not too hard. The homework's not impossible. Taught this class last semester. Some students found it hard, but they were ultimately able to do it. So it's going to be okay. You can do it. Believe in yourself. Now, as far as the hints, as far as these two programs being hints, they are very good hints for the homework. You can't take either of these and modify it directly into a correct homework. But together, these two examples should point you in the right direction. They really give you everything that you need. Now the homework is to make a guessing game. You have two characters. The user guesses. If the guess is wrong, then one or the other character gives a hint and says, your guess is too low or your guess is too high. So there's going to be a loop because there's repetition. And there's going to be an if statement because you have to, at least one, because you have to check whether the guess is too high or low. There's probably going to be more than one because we need to check it. We need to check if it's right. Well, I shouldn't say that. Actually, I don't think there will be more than one. Think about it. You need to check whether the guess is too high or too low. If it's equal, then you should stop looping, probably. So I'm telling you what you need to do here. Going through it with you. You know how to randomly generate a number. I've shown you that just right here. Randomly generate a number. Then, and you know how to ask the user for a guess. You know how to repeat, and you know how to do an if statement. And that's all you need to do. But knowing exactly what order to put it in can take a little time. Best way to do it probably is kind of a trial and error type of approach. Just, you know, if you don't know, try to think about exactly what you need to do and start writing it out. Start saying, okay, I'm going to do this, I'm going to do this, I'm going to do this. And then check yourself. Go and say, okay, is this going to work right? And if it's not, then say, okay, how can I fix it? What do I need to do? Do I need an if statement? Do I need a loop? Do I just need a statement here? And do what you need to do to fix it. And I think that's all you need. So you're going to generate a random number. Then you're going to ask the user for a guess. And then you're going to check if the guess is right. If it's not right, you're going to figure out whether it was too high or too low, give the user a hint, ask the user for a guess again, check if it's right. If it's not right, check if it's too high or too low, and give the user a hint, ask the user for a guess again, check if it's right. If it is right, then you say, that's right, and have them do a little dance. And don't worry too much about the dance, by the way. You can just make them spin if you want. I don't really care too much about the dance. Make them do something, but it doesn't have to be anything complicated. What I care about is the algorithm. So I just stepped through it with you. What I did was I went through, traced through an execution of the program with you. You can take that and use that, what I just did, to write out the code like we did before. So I encourage you to start this soon, and it might take you an hour or 2 hours to do this. This is probably the hardest homework in the class. It's important that you do it because you need to be able to do this type of thing for the final project. But even though it's the hardest homework in the class, it's not too hard. It's not impossible. You can do it. Just might take a little while to think about it. If you're having trouble, ask on IRC, ask me over email, but preferably ask me on IRC because probably other people are having trouble too. If you don't have anybody to work with and you want someone to work with, let me know, and if I have two of you who don't have anyone to work with, I'll put you in a group together. Alright, that is all for today. Good luck with this homework. I hope you find it challenging and fun.